This topic, signal flow graph, helps in converting any complex block diagram into a simple signal flow graph and to get the transfer function of that. Okay, easier method to calculate the transfer function of that without moving the takeoff point or the summing point ahead the block or behind the block. Okay, without doing that we can find the transfer function using this signal flow graph. Now, these signal flow graphs are the simplified version of the block diagram. Okay, for example, if I have this block diagram for a system, let this be G, this be H minus, I can write this in a form of signal flow graph. Okay, this is my R, this is my C. This is the equivalent signal flow graph for the given block diagram. Okay, it can also be defined as a graphical means of portraying the input-output relationship between the variables of a set of linear algebraic equations. That's right. A signal flow graph can be defined as a graphical means of portraying the input output relationship between the variables of a set of linear algebraic equation. Okay, so in this way we can define signal flow graph. There can be of course another definition possible for this, but this is one definition. Okay, now we'll see what are the basic elements of a signal flow graph. One question from signal flow graph is quite expected. Signal flow graph contain nodes. Okay, the nodes, these are the junction points. Second, they contain branches. Okay, the branches connects the various nodes. Okay, now how they connect, that depends on the cause and effect equation. Signal can transmit through a branch only in one direction of the arrow. Okay, so on the branch we make a arrow. That arrow will decide the direction of the transmission of signal. Okay, for instance, I have one here, I have one point here, this is my point y1, this is my point y2. I am going from y1 to y2 with gain a12, that means y2 equal to a1 to y1. Okay, so this branch is connecting my 2 points y1 and y2. Now this can be further connected to some other node. Okay, then again there will be different branch for that. Okay, likewise we connect all the nodes with the help of branches. For example, consider the following set of algebraic equations. We will draw this algebraic equation with the help of signal flow graph. Okay. Okay. First equation is y2 equal to a12 y1 plus a32 y3. Okay. Second is y3 is equal to a23 y2 plus a43 y4. y4 is equal to a24 y2 plus a34 y3 plus a44 y4. Last, y5 is equal to a25 y2 plus a45 y4. Now this equation I have to draw a signal flow graph for this. Okay. Now how to start? See, in this there is no equation given for y1, so y1 is my starting point. Okay, this is my y1. From y1 I can go to y2. Okay, now the first equation y2 equal to a12 y1 plus a32 y3. Now going from y1 to y2 I can multiply it by a12. Okay, but y2 is also a sum of another point y3, so let this be y3 another point, and from here to here is coming as a32. Okay, so now this particular thing satisfies equation for y2 equal to y a12 y1 plus a32 y3. Okay, next, now coming to point y3. y3 is a summation of 2 points y2 and y4. Okay, a32 a43 y2 to y1 a23. Okay, so this particular thing satisfies two equation. First is this one, another one is y3 equals to a23 y2 plus a43 y4. This particular node acts as a summation of 2 points. So the two branches which coming to this particular point is y2 branch and y4 branch. y4 branch, whatever it is there, multiplied by a43, and y2 branch, whatever it is there, multiplied by a23. Okay, next, now taking both the equations together, let this be point y1, this be point y2, this be point y3, y4, and lastly y5. y5 is a summation of 2, y2 and y4. So from y2 I can take one point and can take that to y5, that to be multiplied by a25. Again, for getting y5 I need to multiply it by, I need y4 also, so y4 can also reach there with point a45. Okay, this is already there, a23, a32, A12, A43. Okay, y4 is also equal to A24 y2, A24, A34 y3 multiplied by A34 and A44 y4. That means this point is coming from y4, originating from y4 and coming to y4 itself. So this is A44. Okay, this completes the signal flow graph for the given algebraic equations. Okay, so this way we can draw for any algebraic equation the signal flow graph. Okay, now directly coming to the main topic, now we will see the general gain formula for any signal flow graph. Okay, this general gain formula help us in solving a tedious block diagrams. Okay, those tedious block diagrams which may be difficult to solve direct using a similar procedure for either shifting the arrow and then converting a loop to a simple any feedback loop to a open loop function and then finding the overall transfer function. With this general formula we can find the input output relationship for any complex to complex signal flow graph or complex to complex block diagram. Okay, first we'll see for the signal flow graph. First we will see what are the various terms present in this gain formula. Okay, overall transfer function T is equal to C by R is equal to summation K equal to 1 to N Tk delta K upon delta. Okay. C is input node, sorry, not C, this is R, input node variable. C is output node variable. T is gain between C and R. N is equal to total number of forward path. Forward paths are the path which takes the input, which are from the input node variable to output node variable. Okay, Tk is the gain of the kth forward path between C and R. Okay, Tk is the gain of the kth forward path. Now what is delta? Delta is equal to 1 minus summation of M PM1 plus summation of M PM2 minus summation of M PM3 plus dot dot dot. Okay, where PM are PM1, PM2, what are these? These are the gain product of the mth possible combination of R non-touching loops. Combination of R non-touching loops. So when R is 1, that means 1 non-touching loop. When R equal to 2, that means 2 non-touching loops. When R equal to 3, that means 3 non-touching loops. Okay. The range of R is 1, can lie between any of these regions. Okay. What is non-touching loop? The two parts of a signal flow graph are said to be non-touching if they do not share a common node. Okay, so this is the formula and these are the various components of this formula. Now we will see some problem which will make the understanding of this formula more clear. Okay, consider this signal flow graph. It's a very typical signal flow graph. Y1 to Y2. It goes with gain 1. Then Y3. It goes with gain G1. Y3 to Y4 goes with gain G2. Y4 to Y5 goes with gain G3. Y5 to Y6 G4. Y6 to Y7 1. Okay. From Y3 to Y2 I have one feedback, gain is minus H1. From Y3 to Y6 I have one more forward path with gain G5. From Y4 to Y5 I have one feedback path with gain minus H2. From Y2 to Y5 I have one feedback path with gain H3. Okay. From Y6 to Y6 yes, one with minus H4. Okay, so this is a signal flow graph for which we have to find the total gain Y7 by Y1. Okay, see the solution for this. The total gain T is equal to Y7 by Y1 is equal to summation k equal to 1 to n Tk delta k upon delta. Okay. So the number of forward path in this signal flow graph is 2. One is G1, G2, G3, G4 and G1, G5. With this forward path, the first one, G1, G2, G3, G4, all the nodes are covered. Okay. So there is delta k, delta 1 is equal to 1. Okay. But with the forward path G1, G5, delta 2 is equal to 1 minus G3 H2. So this is equal to 1 plus G3 H2. Okay. So this is for the forward path. Now coming to the overall value of delta. 1 minus sum of all non-touching loops. Okay. One non-touching loop. Okay. So in this there will be 1 plus minus of G1 H1 minus G3 H2 minus G1 G2 G3 H3 minus H4. Okay, this is the single loop. Now taking two loops at a time, in that I will have one G1 H1 dot G3 H2. Okay, another one is G1 H1 and then multiplied by H4. These are the two loops taken one at a time. Next is G3 H2 and H4. Okay. Next is one loop is G1 G2 G3 H3 and H4. Okay. Now this is for the two loops. Last one is take three loops at a time. If there is a possible combination the three non-touching loops, then that is, yes, in this case we have three non-touching loops. One is G1 H1 multiplied by minus G3 H2 multiplied by minus H4. Okay. So the overall delta is equal to 1 plus G1 H1 plus G3 H2 plus G1 G2 G3 H3 plus H4. This for the single loops. Then two loops at a time, G1 H1 G3 H2 plus G1 H1 H4 plus G3 H2 H4 plus G1 G2 G3 H3 H4 plus G1 H1 G3 H2 and then H4. This is my delta. Okay. Now the overall transfer function will be y7 by y1 is equal to G1 G2 G3 G4 plus G1 G5 1 plus G3 H2 upon the value of delta. The value of delta is the same what we have found earlier. So this is the transfer function, or this is the gain from y1 to y7. Okay. So this was one problem, typical problem, but these type of typical problems are not expected, but these are useful in understanding the concept of signal flow graph and the Mason's gain formula. Okay. Now we will see one problem in which a block diagram is converted to signal flow graph, and then the overall gain is found. Okay, overall transfer function is found for that. First I will draw the block diagram, and then we'll convert that block diagram to a signal flow graph, and then we'll find the transfer function. This is H2, this one more feedback path. Okay, so this is the overall block diagram. We need to convert this block diagram to a signal flow graph, and then from signal flow graph we can directly find the gain of the system or the gain of this. Now, to convert this signal flow graph, or to convert this block diagram to a signal flow graph, we have to consider this summing point as a node. Okay, so let, how many nodes are there, how many summing points are there? 1, 2, 3 and 4. Okay, so I will also have, this is my R, this is one summing point, let this point be y1, another summing point, let this point be y2, let this summing point be y3, y4, and then finally output C. Okay, so I have 4 summing points. From the output C, there is one coming to the 0.51 feedback. Since at this summing point in the question I have here minus sign, so in my signal flow graph the multiplication factor will be -1. Okay, this will be 1. From y3 to y2, y2 to y3 I have gain g1. From y2 to y4 I have gain g2. From y4 to output I have gain g3. Okay, from y2, from y3 after this gain g1 I have to take it to point C, which is multiplied by summing factor g4. Okay, from this point after g2 there is a feedback to y2. the value of this is minus h1. Okay, from C to this point I have one more feedback, and the value of this feedback is minus h2. From this C I can take it to another C multiplied by gain 1. Okay, so this is the signal flow graph for the given block diagram. Okay, now directly we can find the transfer function. See, the number of forward paths in this one is G1, G2, G3. Okay, another one is, with this G1, G2, G3 it covers all the nodes, so there will be no delta K or delta 1 in this case is equal to 1. Another one is G1, G4 divided by delta. Now what is the value of delta in this case? Delta in this case is 1 minus non-touching loops, single non-touching loops. Okay, then we will take two non-touching loops. First one is minus G1, G2, H1. Okay, then minus G2, G3, H2. Okay, then G4, H2. Then G1, G2, G3, the outer loop. Here the feedback gain is minus 1. Okay, then G1, G4. There are no two loops which are non-touching all. Okay, so the overall transfer function will become 1 plus G1, G2, H1 plus G2, G3, H2 plus G4, H2 plus G1, G4 plus G1, G2, G3. So this is my delta. This will be the numerator part of my transfer function. Okay, so in this way we can solve the given block diagram transfer function with the help of signal flow graph. Okay, we will take up more problem from this topic of signal flow graph, which will clear the more concept about this. Okay, this is very simple. We just have to remember the formula and just need to put the formulas correctly. Okay, there will be problem when we put the non-touching loops to non-touch, when it comes for the non-touching loops. That is the basic problem which comes in this. When we will solve the problem, we will clear that thing also.